Good morning, class. Even when I'm not there, you can't get away from me. So I recorded a video here to continue our discussion on trigonometry. So let's see if we can get this to work. Well, what we did last time, so have some notes out so you can take some notes this morning. And what we looked at last week was, or not last week, but the last time we met on Monday, we looked at these 6 trig functions. And the main point here is that each one of these functions represents a ratio of 2 sides of a right triangle. And so if I've got a right triangle, and there's my 90 degrees, and I define one of the sides to be some unknown angle theta, then I can come up with a ratio of two of the three sides according to these 6 formulas. But if this is theta right here, then this is going to be what we call the opposite side. It's the side that's directly across from the unknown angle. This is the side that's right next to that, so we call that the adjacent side. And this is the hypotenuse. So there is the hypotenuse. And so for example, if I write the sine of that angle, that is going to be, this represents the number, which would be the side opposite that angle divided by the hypotenuse. Now obviously the sine and the cosine are always going to be less than 1 because the hypotenuse of a right triangle is always larger than either the opposite or the adjacent side. Now what I want us to look at next is, we'll call this Roman numeral 2 in our notes, is I want us to look at the 30 degree and 45 degree triangles, right triangles. And we'll come up with the ratios for these triangles. Let's consider the 45 degree triangle. That means that I've got one right angle, and then the other 2 angles are splitting the remaining 90 degrees. That means then that if I call these sides length 1, I can come up with the hypotenuse using Pythagorean's theorem. Because Pythagorean's theorem says that c squared is a squared plus b squared. C is my hypotenuse. So the length of that hypotenuse is going to be the square of that hypotenuse is 1 squared plus 1 squared. So that's c squared is 1 plus 1. Take the square root of both sides, I get the square root of 2. So this side over here is the square root of 2. So if I start off and I say, okay, sine theta is going to be opposite over hypotenuse. That means for a 45 degree triangle, and we're letting this be theta, the side opposite is 1, and the hypotenuse is the square root of 2. If I rationalize that, I'm going to get root 2 over 2. So what we're saying is that all triangles, all right triangles in the universe that have a 45 degree angle right here, the ratio of the opposite side from the 45 degrees divided by the hypotenuse is always going to be this same ratio. It's not going to change for all triangles with that 45 degrees. If I do cosine theta, that's going to be adjacent over hypotenuse, which is going to be 1 over the square root of 2 again, because my adjacent side is this 1. I rationalize once again, get the same answer, square root of 2 over 2. If I take the tangent function, that's the opposite side divided by the adjacent side. And so that's going to be 1 over 1 or 1. Okay, so keep in mind, these are all equal to, this is the sine of 45 degrees. So this is something that is always true. A right triangle with a 45-degree angle is always going to have that ratio, no matter how large or small the triangle happens to be. The ratio is what will stay the same. That's true. And then, of course, that's true as well. If I pull up the calculator here, hopefully you can see this on the video. If I can find my calculator, there it is. So this is the calculator. Maybe you can see that. If I put myself in degrees mode, I'm in radians, but there I'm in degrees, and I hit 45 and then select tangent, it tells me the answer is 1. Now, if I do 45 and hit sine, it's going to give me this long number here, which obviously is an irrational number. It's a non-repeating, unending decimal. And so basically, if I was using my calculator here, what that's telling me is, let's go back to it. So the sine of 45 degrees is this long number. So sine of 45, according to the calculator, is an irrational number that looks something like this. But if I wanted to get the exact value, what I can do with my answer displayed right here, if I hit square, which is right here, you'll notice that it gives me an answer of 0.5. So what that means then is that if I take the sine of 45 degrees and square it, I got 0.5 exactly. It was not an irrational number. It's exactly 0.5. So if I square root both sides again, basically what I have is I'm back to sine 45 degrees, and I have the square root of 1/2, which is, using the rules of radicals, square root of 1 over the square root of 2, which is 1 over the square root of 2. And then when I rationalize that, I come back to my radical 2 over 2, which is what I knew was going to be true in the first place. So that's just one way that you take your calculator that's giving you an irrational number and how you convert it back into the true exact answer for your problem. Now, the next one that I wanted to look at is the next triangle I want to look at is the 30, 60, 90 triangle. And this triangle, we're going to start to examine this one with the trig functions by first starting with an equilateral triangle. So if it's equilateral, that means that the sides and the angles are all the same. So it's got 3 60-degree angles. And I'm going to let the lengths of the sides all be 2. And you'll see why that is in just a second. What I'm going to do now is I'm going to draw a line that is going to split this side right here. So I'm going to start from this corner and come up here, and I'm going to make that a right angle. What that's going to do, and you probably know this from geometry, but if it's an equilateral triangle, that means this length of 2 is going to be split into 1 and 1. This angle of 60 degrees is now cut in half, and it's now a 30-degree angle. So I have just created a 30, 60, 90 triangle where one of the sides is length 1 and the hypotenuse is length 2. What I'll do is I'll go ahead and redraw that over here. I'm just going to put it right side up like this. So here's my hypotenuse. That's the length 2. There's the right angle. There's my length 1. This is my 60-degree angle. This is my 30-degree angle. So all that I'm missing is the length of this other short side. So using Pythagorean's theorem, I know that c squared is 2 squared. One of the short sides is 1, so that's squared. And so what I get is 4 equals 1 plus the other short side squared. And that takes me to b squared is equal to 3. And square rooting both sides, I get b is square root of 3. So this other short side is the square root of 3. What I can do now is just like I did before. I could write, if I wanted to, and I do, I'm going to write 6 trig functions. And I'm going to write them for 60 degrees. So the sine of 60 degrees is going to be the ratio of the opposite side over the hypotenuse. So across from 60 is square root of 3, and the hypotenuse is 2. So all right triangles in the universe that have a 60-degree angle, if you form a ratio of the length of the opposite side over the hypotenuse, you are always going to get that ratio, no matter how big or small the triangle is. Cosine of 60 degrees is going to be the ratio of adjacent over hypotenuse. That's going to be 1 over 2. There's my adjacent, there's the hypotenuse. And then tangent of 60 degrees is opposite over adjacent. And that would be the square root of 3 over 1, or just the square root of 3. Now I could also come up with the other ones, cosecant of theta, which is the inverse of sine theta. That would be 2 over root 3. And when I rationalize that, I would get 2 root 3 over 3, and so on and so forth. Now you're probably a little bit ahead of me here and realizing that when we come up with these trig functions, we're not going to be using these triangles. We're going to be using the unit circle. Okay, so we'll talk about that in just a minute. But I'm just showing you here where these trig functions come from. They come from these ratios of sides. And so we've just kind of shown that to ourselves by example using these triangles, 30, 60, 90, and the 45, 45, 90 triangle. What I want you to do is take a look at your guided exercise. I think I handed that out to you last time. We did some of it. I think this is what we completed last time. But I want you to turn on the back page because we did not do those. And I'm going to have you do those now. I'm going to zoom in here a bit. And this is the first one on the back page of that guided document. So I'm going to work this one, and then I'm going to let you do the other two. But I've got the 2 triangles that we were just working with here on the back. I'm going to use those to come up with these ratios. So cosine of 30. Well, I come up here and I see that there's my 30 degrees. And I know the definition of cosine is the adjacent over the hypotenuse. So relative to this angle, radical 3 is the adjacent side. So I put radical 3 divided by the hypotenuse, in this case, is 2. So there's the answer of cosine 30. Now, when I go to secant 45, my thought process is, okay, there's my 45-degree angle. Now, I do know that secant is the opposite of cosine, right? And so I'm going to write that down. It's 1 over cosine of 45 degrees. Now, I know cosine is adjacent over hypotenuse, so that means that secant is going to be hypotenuse over adjacent, because it's the inverse. Secant and cosine are inverses of each other. So basically all I have to do to get this is invert this, and I would have 2 root 3. and then rationalize that, and I'm going to get 2 root 3. This will be equal to 2 root 3 over 3 for the secant of 45. Actually, that's not true. I used the wrong triangle. So let's erase this. I could hear the groans already, even though I'm just recording this. So I'm using the 45-degree triangle here. Let's go back to my green here. So let's try this again. Secant is 1 over cosine. I know that cosine is adjacent over hypotenuse, so it's hypotenuse over adjacent. Now I'm going to the 45-degree angle. My hypotenuse is the square root of 2, and my adjacent side is 1. So radical 2 is the secant of 45 degrees. Now, this next question is asking me to take the sine of pi over 4 minus the cosine of pi over 4. Pi over 4 is 45 degrees, right? Because pi is 180. So pi over 4 is 180 divided by 4, which is 45. So with the 45-degree angle, I'm going to take the opposite side over hypotenuse minus the adjacent side over hypotenuse. This is the sine, this is the cosine. What I end up with is 1 over root 2 minus 1 over root 2. Answer is 0. Okay. So then what I want you to do now, and our substitute teacher, I guess, could go ahead and pause the video. I want you to finish the other 2 parts of this. There is the middle one, which is the student, or the we do, and this is the student does. So I'll pause that now and let you work on those for about 5 minutes, and then we can resume. Okay, so these are the answers here if you want to check your answers. I hope I did those right. Sine 30 is 1/2. Pi over 3 is 60 degrees, so tangent 60 is root 3. Tangent 30 is going to be radical 3 over 3. Moving over to this student does part, cosecant 45 should be root 2. Cotangent of pi over 3, which pi over 3 is 60 degrees, is root 3 over 3. And then tangent of pi over 4 minus cosecant pi over 6. Tangent of 45 is 1. Cosecant of 30 is 2. So my answer to that expression is negative 1. All right, a few other things I wanted to mention, and then we'll try to wrap this up. Let's talk a little bit about Roman numeral 3. We'll talk about our calculators, using our calculators. And I'm going to change my ink. There we go. Calculators. Just some tips in using our calculators. Number 1, we have to be in the right mode. On your TI-84, you can change the mode from degrees to radians, depending on what you're taking, what units your angle measurement is in. So if I put my calculator in degrees mode, and I press the tangent button, and I enter in the number 45, my calculator is going to assume that I mean 45 degrees, and it's going to give me the answer of 1. However, if I change the calculator, not myself, but change the calculator to radians mode, and I put in tangent 45 in my calculator, it's going to assume that I mean 45 radians. It's going to give me a different answer. I'm in degrees, so I hit 45 and tangent, I get the number 1. But if I put myself in radians mode, and take 45 and take the tangent, I get 1.6197. I get a number that is an incorrect answer because it's assuming those are radians. So we have to make sure we are in the right mode depending on what units our angle measurement it is. Also, we have to make sure that we use the parentheses carefully. If I'm using radians and I am trying to find the tangent of pi over 6, now I know that that's radians because it has a pi in it. And since there's no degree symbol also, it has to be radians. And so when I put this in the TI-84, when I hit the tangent button, it's going to give me that on the display. So I'm going to go grab the pi. I'm going to click on the pi button on my calculator, and then I'm going to hit the division key, and then I'm going to hit a 6, and I'm going to close it off. And then I'm going to hit equal, and it's going to give me the answer. So if I do that here, there's pi divided by 6 equals, and then I'm going to hit tangent. And what I get is 0.577, etc., etc. Now, I want to express that as an actual number, so what I'm going to do is I'm going to square that answer, and you'll see that I get 0.33333, which is 1/3. So that means that the tangent of pi over 6, if I square that, which I just did on the calculator, I get 1/3. That means then that the exact value of tangent pi over 6 is the square root of 1/3. That's where this 0.577 came from. That's 1 over root 3, which is root 3 over 3. But my point being, you have to make sure that you close off your parentheses so that you're only including the angle in this measurement. So for example, if I asked you to evaluate an expression that looked like this, tangent of pi over 6 minus 2. Now you know what I mean. What I mean when I write this expression is you're going to take whatever the tangent of pi over 6 is and get that answer, and then subtract 2 from that answer. But if you put it in the calculator, in radians mode, you hit tangent, and you hit pi divided by 6, and then minus 2, and then hit equals. It's going to assume that that's what you mean. So you have to be careful to close the parentheses off here when the angle ends. Okay, so I think that is pretty obvious, but definitely worth mentioning. The other thing that we need to mention with our calculators so that we don't make any mistakes is we want to remember that if I'm trying to find secant, which I know is the inverse of cosine, I am not going to use on my calculator that button. In other words, cosine to the -1 on your calculator does not mean this right here. You may think that it is, and it would make sense if you thought it was, but it is not. So what does that mean? If I wanted to find the secant of 30 degrees using my calculator, what I have to do is realize that that's 1 over cosine 30 degrees, because secant and cosine are inverses. So on my calculator, I'm going to take cosine of 30 degrees and get an answer, and then I'm going to invert that answer, and that's going to give me the secant. So cosine of 30 degrees so I do 30 and then cosine, I'm in radians, so I go back to degrees. So 30 cosine is 0.866. I squared that. It's 3/4. And the square root of that is radical 3 over 2. So what does that mean? That means if cosine 30 is that, then that means that secant 30 is that, which would be 2 root 3 over 3. And we'll get more practice with that as we go along. All right, last thing I wanted to talk about here in section 4.2 is some applications. I'll do 2 application problems, and then we'll talk a little bit about the unit circle. So where does all of this stuff get used? Well, I'm going to go grab a figure. I'm going to grab this guy here. Come back here. All right, there we go. All right, now if I wanted to find the height of this building, I guess I could climb up to the very top up here, and I could drop a tape measure or some measuring device to measure the vertical distance, but that's pretty much impossible. So what we're going to do is use trigonometry to figure out what the height of the building is. What I would do is I would walk some distance away from the building. So now instead of on top of the building, I'm over here. And using a scope, I'm going to shoot a line of sight that goes from the ground here, and it's going to go all the way up, and I'm going to zoom in and focus right there at the top of the building. That device that I'm going to use is going to tell me that I have just created that 65-degree angle, or whatever it happens to be. So I measure this, what we call angle of elevation. And so the device that I use to look at the top of the building is going to give me that. Then I can more easily measure this linear horizontal distance from the base of the building out to where I looked up at the top of the building, 340. So this is a triangle. It's a right triangle. Assuming, of course, my building is at a right angle with the ground. And so what I'm going to do is I'm going to look at this triangle, which is this. I have some unknown height over here, h. And I've got a side over here, which is 340 feet. And that's a right angle. So relative to 65 degrees, this is the opposite side. This 340 is the adjacent side. So I ask myself, which of the functions, trig functions, includes opposite and adjacent? And the answer to that is tangent. So I'm going to write down the tangent formula. Tangent theta is the side opposite over the adjacent. I'm going to plug in what I know about this problem. I know the angle is 65 degrees. I know the opposite side from 65 is the unknown height. And the adjacent side is 340 feet. I can solve this for height by multiplying both sides by 340. So it's going to be tangent of 65 multiplied by 340 feet. Keep in mind that the tangent function and all of the other functions are unitless because they are ratios of sides. So my answer here is going to be in units of feet. I pull up my calculator, make sure I'm in degrees mode. So I do 65 tangent, happens to be 2.1445, and then I multiply that by 340. And I get an answer of 729. Let's see, 729.13 feet. So approximately 729 feet. That's my answer. One other application problem. And I'll go and grab another figure from the textbook right here. paste that over here. Okay. All right, so this is another example here, and what we're trying to do on this is a solar panel, and we're trying to find the area of the solar panel. Now, I know for a rectangle area is length times width. I've got the length, but I need this width right here, that distance, the width. I'll label that W. I know that the distance from the top of the solar panel down to the mounting surface is 5 feet, and this angle is 54 degrees. So if I take a look at this triangle and draw it, and look at it from the side, I've got 54 degrees, I've got 5 feet, and I need to know that hypotenuse, which I'm calling W for width of my rectangle. So relative to 45 degrees, this is the opposite. This happens to be the hypotenuse. So I ask myself, which trig function has the opposite and hypotenuse sides? And that is the sine function. So I write sine of 54 degrees is the opposite over hypotenuse. My opposite side is the 5-foot side. My hypotenuse is the unknown width, or W. Well, I can multiply it. Now, basically what I'm saying here is I now have transformed this into an algebra problem. I'm trying to solve this equation for W. Using algebra, W is 5 feet divided by sine of 54 degrees. I go to my calculator. I take 5 divided by 54 sine equals, I get 6.18. And that's units of feet. Okay. All right, we've gone about a half hour. I only have really one other thing that I wanted to show you here. And that is the unit circle. Now on Friday, I'm going to give you your first quiz on the unit circle. And all that I want you to do on that quiz is I'm going to require you to give me all of the standard angles in both degrees and radians. On that quiz, I'm going to give you a copy of this. I mean, I'll actually give you the template with all the angles missing. So there's the unit circle. So let's review how it is we come up with these angles. I'm not going to expect you to know these ordered pairs on the edge of the circle. But a couple of things to keep in mind, right? This is set upon an XY axis. So this right here is my X axis. This is my Y axis. Like that. It's a unit circle, meaning it has a radius of 1. So this point out here happens to be 1, 0. And now my job is for each of these points along the perimeter, putting the angle that's formed for that particular line. I know that 180 degrees is pi radians. So I'm just going to come over here and say pi and 180. Now I'm going to work with degrees first. So if that's 180, I know that this up here is 90 degrees. So I'm just saying that that angle, as I rotate around, is 90 degrees. Okay. Then what I can do, get my pen back here. That's 90, 180 plus another 90 is 270, and then plus another one is 360. So this is both 0 degrees and 360. Now what I'm going to do is I'm going to split the 90 degrees in half. That's what this line represents right here. That represents the 90 split in half. Creates two equal angles. So that's 45 degrees. Now I'm going to add 45 as I go around. This is 45. Plus 45 is 90. I come over to this one, which is another 45 degrees of rotation. That's 135 degrees. Another one over here takes me to 180. 45 degrees more takes me to 225. 45 degrees more, 270. 45 degrees more takes me to 315, and then I end up at 360. Now these other two sides right here, those are not splitting the 45 in half, because this happens to be 30 degrees and this happens to be 60 degrees. So as I rotate around this, all I'm doing is adding 30 degrees each time as I skip along here. So this is 30 degrees. If I add another 30 degrees, I come to 60. Add another 30 degrees, I come to 90. Add another 30, 120. Another 30, 150. Another 30, 180. Another 30, 210. Another 30, 240. Another 30 takes me to 270. Then I come to 300. And then finally 330, and then 360. So I've labeled basically all of my angles in degrees. Now let's go with radians. It's going to be much the same thing, nothing really different here. This is going to be pi. Okay. Now if I split 180 in half, I get 90. So this over here is going to be pi over 2, 1/2 pi. So if I go around, this is 1 pi over 2. Coming around here is 2 pi over 2, which is just pi, which would mean this is 3 pi's over 2, down here at 270. Adding another one would put me at 4 pi over 2, which is 2 pi. If I cut the pi over 2 in half, right, pi over 2 divided by 2 is pi over 4. So that's what 45 degrees is. That's going to be pi over 4. Now what I'm going to do is as I go around, instead of adding 45 each time to get to these middle lines, I'm going to add a pi over 4. So this is 1 pi over 4. This is 2 pi over 4. That would be 3 pi over 4. This is 4 pi over 4, which is obviously just pi. This one right here is 5 pi over 4. This is 6 pi over 4. And over here, 7 pi over 4 goes with 315. This over here is pi over 6, 30 degrees. If I add pi over 6, I get 2 pi over 6 for 60 degrees, which is pi over 3. Add another one. This is 1 pi over 6, 2 pi over 6. This would be 3 pi over 6. This would be 4 pi over 6. This would be 5 pi over 6, and then 6 pi over 6, and so on and so forth. So I'll leave it there, and the quiz that we're going to have next week is going to be you taking this blank template and filling it in just like I did. Okay. Now, what I want you to work on is an exit slip. So here is your exit slip. So get out some paper, and I will tell you what to do. You're going to work a few problems for me. So this will be your exit slip for 12-7. I'm going to give you a triangle, right triangle. This is 18 feet. This is 32 degrees. I want you to find this side right here with the question mark, and give that to me as a decimal. Okay, and then secondly, I'm going to give you another triangle. Up here, this is going to be 50 degrees, and this is length 5 centimeters, and I want you to find the question mark side right there. Okay, that is your exit slip. Work on that, and our substitute teacher will collect that from you at the end. I'll see you all on Friday, And don't forget about the quiz on the exit slip.